Well, thank you for the introduction. So yes, my name is Xavier Guérin, and speaking of the middle of nowhere, I come from Beau in Burgundy, and this is much smaller than Clermont-Ferrand, but we have better wines. I'm very happy today to be here as a new member of OW2, and also very happy to have this opportunity to talk about my company and also one of the key open source projects that I'm maintaining. So first, we started business in 2021 after I spent a decade in New York, mostly working for IBM Research. The company offers research and development services in high-performance computer systems and networks. We are very small teams, 2 PhDs and 2 research engineers, but we are looking into a variety of different centers of interest. Many are industries. We are looking at projects in many industries, finance, banking, telcos, and defense as well. But we are also working on multiple hardcore computer science topics like systems and networks, programming languages and compilers, distributed cloud computing, data processing, and hardware design. Last but not least, we are dedicating a fair amount of time to build and maintain open source projects that you can find on the GitHub of the company. One of them, here are 3 examples of those projects. One is Bitstring, which is a fairly popular bit manipulation libraries for OCaml, because there is a story where I used to develop hardware using OCaml back in the days. There is Tulips, which is an ultra-low latency user space TCP IP stack that works with some of the most performing low latency network interface on the market. And the last one is OpenStreams, which is a cloud-native streams processing platform. And this is that last project that I'm really happy to talk about today, because in my opinion, this is probably the most impactful and consequential project that we are maintaining at the lab. OpenStreams is the open source version of a very mature IBM product of 15 years called Streams. I worked at IBM for 8 years. I worked in the Streams department for 4, and I also led the effort in 2020 to open source that product under the Apache v4 license. And I like to describe OpenStreams as a cloud-native runtime for distributed stream processing applications, and it's quite a mouthful, so let's try to unpack what it actually means. First, what is streams computing? Streams computing is a model of computation where applications that implement control on data flows are going to process multiple high-volume sources of very small data. Think a few bytes to like 100 bytes. That processing has to be fast enough to look like real-time, even though we don't really implement any kind of like hard or soft real-time, but it has to look real-time to the user. And it also needs to auto-scale, meaning that it needs to scale up and down depending on the volume of the input of the data. Because of this, it has to be distributed. It has to run on multiple machines. And for that, it has to have multiple services like application scheduling and deployment, resource management, fault tolerance, state consistency, and some other ancillary services like monitoring, reporting, data access, and persistence. Last but not least, it is cloud native, meaning that it is highly portable. It can run on any cloud. It can run also on your laptop and IoT devices. And it's really easy to integrate with other applications, distribute and manage, and also govern. This piece is probably the main differentiator between OpenStreams and the IBM Streams version, where IBM, to distribute the runtime, had to build its own orchestrator, its own platform, because they started 15 years ago. And back then, there was no alternative. It's not like you could go at Radio Shack and get your own Kubernetes on a CD-ROM. It didn't work like this. So they spent 15 years working on this platform, but it was so complex that eventually it became kind of like siloed. So what we decided to do was to simply remove this 1.2 million lines of Java horrible code and use Kubernetes instead to provide all of those services. And we were right, because at the end of the day, we won on 4 key metrics, which are overhead, compatibility, flexibility, and cost. So overhead, building a consistent, fault-tolerant distributed platform is probably one of the most complicated software engineering projects that has ever existed. IBM did not have a choice to do it 15 years ago, but when you have one that has been built by Google that is available to everyone, to us it made sense to actually try to use it. Like I said, the Java platform for IBM Streams was 1.2 million of code. When we removed it, that was one hell of a commit. Compatibility. If anyone has done ops in their life, deploying third-party application to try to work together is always difficult because you always have like incompatibilities, have to work on the ports and the IPs and all these kind of things. With Kubernetes, as long as your application run on kubes, configuration becomes suddenly very easy. And OpenStreams now enable this because it works as a regular, fully integrated workload on kube, and as long as your services are on kube, it connects to them semi-automatically. The third one is a big one. It's flexibility. When we used to deploy applications running for this runtime on the old streams, you had to have a cluster that had a version of IBM Streams running. It only worked on like specific OSs, hardware. So your application was technically kind of bound to your own cluster. With OpenStreams, you run it wherever Cube works. If it's on a cloud cluster, it works. If it's on Google Cloud, Ali Cloud, whatever cloud, it works. If it's on IoT device that run like K3C on ARM, it works. If it's your laptop, it works. So in terms of pure deployment and ease of use and also development workflow, it's a big win. The last one is cost, because it's such a big project, cost is always an issue. The team used to be 60 to 70 people. Out of these 70 people, 45 were dedicated to the platform. And the remaining were researchers, probably salespeople, and some support people. So you can see that for the business logic, the team was actually extremely small, and the huge cost center was the platform. And being able to leverage something that already exists, that is proven to be stable, and that is used by everyone, is a huge saving on costs and can allow to maintain this very large project with a very, very small amount of people. So if you are curious to know how we did this, because in total the code base was 2.2 million lines of code, we halved it and we added some knowledge to make it work nicely and natively on Cube by exploiting some often less spoken of features of Cube, which are global state management. I invite you to read that paper. It's on archive, written by the team in 2020. I said my piece. I have like 1:30 for questions if you have any, but thank you very much, and again, I'm very happy to be here.